Hello and welcome back to this video on prospective fault current. Now regulation 612.11 requires that the prospective short circuit current and prospective earth fault current shall be measured, calculated or determined by another method at the origin and at other relevant points in the installation. This is necessary to enable the inspector to determine whether the protective devices can safely contain the size of fault currents during fault events, which could otherwise cause injury to persons or damage to buildings by fire or explosion. The breaking capacity of a protective device will generally have to be greater than the maximum prospective fault current determined. Therefore, the inspector will need to know what the breaking capacity of the relevant protective device is. For a BSEN 60898 circuit breaker, this is usually identified on the front or side of the device with a value shown within a rectangle. In Test Rig 2, the circuit breakers are 6000 amp or 6 kA rated. This information should be recorded on the schedule of test results in the relevant column for breaking capacity in kA. Please note, however, that circuit breakers are also available with other breaking capacities as shown. This table also provides information on other protective device types such as fuses together with their breaking capacities. Now let's look at the tests that will be necessary to determine the prospective fault current. At the main switch of Test Rig 2, we need to measure both the prospective earth fault current and the prospective short circuit current. The greater of the two will be the prospective fault current. To measure the prospective earth fault current, we set the test instrument to the high current earth fault loop impedance ZS test setting with the function button set to L-PE. Using the 3 lead test probes, we then connect the earth test lead using a crocodile clip to the main earth terminal. Now please note, it's not necessary to disconnect the earthing conductor during this test as we did earlier when testing the earth fault loop impedance external to the installation. We then apply the second probe, which is fused, to the neutral conductor, and the remaining probe is applied to the line conductor L1. We press the test instrument test button and the earth fault loop impedance is displayed together with the prospective earth fault current, which is seen at the bottom of the display screen in amps. It is then necessary to repeat the test to determine the prospective earth fault current of the other line conductors L2 and L3. To measure the prospective short circuit current, it is then necessary to repeat this procedure, but now with the test instrument function set to measure the line to neutral loop, L to N setting. Make a note of the measured values obtained during these tests, which are the single phase values. But before recording the highest of these, remember, it will need to be doubled to take account of the worst case, which could be a symmetrical line-to-line short circuit fault. The doubled value should then be recorded on the schedule of test results as the IPF at dB in kA for the 3-phase distribution board. The inspector would then need to compare this value to the recorded breaking capacity of the protective device to ensure that these devices can safely contain this level of fault current. As an alternative to the measurement method previously described, it's possible to calculate the prospective fault current by using the formula IPF equals U0 over ZE, where U0 is the nominal supply voltage 230 volts, and the earth fault loop impedance external to the installation has been determined by either measurement or by inquiry. Now for Test Rig 2, we measured a value of 0.4 ohms for the earth fault loop impedance external to the installation, which we will use. So using the formula, the prospective earth fault current is calculated as 230 divided by 0.4, which equals 575 amps. But remember, this is the single phase value and needs to take account of the possibility of line-to-line short circuit faults. Therefore, before recording it on the schedule of test results, remember to double the value. Now, to conclude this short video on prospective fault current, it should also be mentioned that there is the option, as an alternative to measurement and calculation, for the inspector to obtain this information by a simple inquiry with the relevant supply distributor, for example, Scottish Power Energy Network, who will typically quote 16 kA for a domestic installation and 23 kA for a three-phase installation. So that concludes this short video on prospective fault current. So now watch the last in the series of the videos on checking phase sequence and functional testing.